e to the power x and log base e of x. E is a very special number. It's to uh, calculus as pi is the geometry. It's this sort of very powerful number. It shows up everywhere. There are various ways you can derive it. If we use a specific case of the compound interest formula, and you wonder about what if the number of compoundings per year goes to infinity, then you get something called continuous compounding, which I'll mention down here. And in it is the number e, which is a limit as n goes to infinity of 1 plus 1 over n to the n. Now here this is, for large values of n, this is a big power of a number very close to 1. So it's sort of a tug of war. Is it big? Is it small? It's in the middle. Its decimal expansion is 2.71828182845 and it goes on forever without pattern. It never repeats because it's not a ratio of integers. It does, here's an expression to give a limit expression. To tell you what E is. E is 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4 plus and so on. You get ever longer products in these denominators. And it converges to this. Now it shows up in all sorts of places, like I say, continuous compounding. You start with a compounding formula from the previous section, second section back. You'll see that, and you let the number of compoundings go to infinity. You get continuous compounding, where like before, P is the present value of the loan, A is its later future value. R will be its continuous interest rate, T is time, then A will equal P times E to the RT. Oh, there's a, now, so okay, E just shows up, it shows up all over the place in mathematics and physics and chemistry and engineering and so on. And since E to the X is an important function, its inverse is important. It's called the natural logarithm, written ln. It's log base E of X. And ln of E to the X is X. E to the ln of X is X, they're inverse functions. E is bigger than 1, so it's an exponential explosion graph like this. And logarithm looks like this. Now, there's why that name natural? Well, it comes from this. If you take this graph, the graph of y equals 1 over x, and you draw a vertical line at x equals 1, another vertical line at x equals k, and you look at this area here. It's four-sided figure, 3 straight sides and 1 curved side. And the area of this figure is the natural log of k. This is something you'll see when you get to the calculus. And so since this is all simple stuff, 1 over x, then this is why natural log is considered natural. That's just some examples. For these next two problems, we use A equals P e to the RT, continuous compound. If the present value is $15,895 and an interest rate of negative 2%, so it's something that's decaying away, depreciation, no doubt, and T equals 16 years, then what's the later amount? All right, well, P e to the RT is A, 15,845 times e to the negative 0.02 times 16. Now, run it through your calculator, about 11,542.14. You lost about $4,000. P is 565, an interest rate, again, depreciating at negative 0.5% for 8 years. What's that? Well, P e to the RT. 565 times e to the negative 0.05 times 8. Work it out. 542.85. Let's ask for what is the natural log of a cube root of a square of e? Well, that's natural log of e to the 2/3. And since natural log and exponential base e cancel, we're left with 2/3. Here, natural log of x is 4.24. What's x? All right. The natural log is 4.24. Then we invert logarithm, get exponential base e. So x equals e to the 4.24. And that's 69.40979. Here's similarly, natural log is negative 3.71. What's x? You take exponential, y equals e to the power negative 3.71, which is about 0.0245. Here we have a principal and interest problem. A principal of $5,000 invested compounding continuously at 8.2% over 12 years yields what future value? Well, that amount is P e to the RT, which will be P 5,000 times e to the power R 0.082 times T 12. So run this through the calculator. 13,375.68. More than doubled, in fact, almost tripled. Here, P of T is 2 times e to the 0.02 T. So this is something that starts out at value 2 and grows continuously at a rate of 27%. What is P at time 12? Okay, well, you plug it in. 2.027 times 12 is about 51. Okay. I think we have completed this.